All right. So I want to welcome everyone to today's Construction R&D Showcase. I'm Mike Matheson, Managing Director of Cognit.ca, and will be moderating today's session. This series is jointly presented by Cognit.ca and the Canadian Construction Association. The R&D Showcases are part of a broader initiative Cognit.ca and the CCA have undertaken to help the construction industry more fully leverage Canada's $14 billion academic research enterprise. Another major element of it is the Construction R&D Hub, which can be found on the CCA's website. Using the R&D Hub, you can see recent construction industry relevant research and search for research, researchers, facilities, and IP that can help you address your company's next challenge. I've posted a link to it in the chat and would encourage you to check it out when you have a few minutes. Our format today will be a 10 to 15 minute presentation, but followed by a 10 to 15 minute Q&A session. If you have questions for our presenter, please click the Q&A button at the bottom of the Zoom window and enter them in the box. I'll then read them out during the discussion portion of the program. For today's showcase, I'm pleased to introduce Dr. Carl Haas. Carl is a professor and a university research chair at the University of Waterloo. He's also chair of the Department of Civil and Environmental Engineering. Dr. Haas will be presenting on digitization for geometric control in prefabrication and construction. And with that, I'm pleased to turn it over to Dr. Haas.
Thank you, Mike, and thank you everybody else for taking time out of your day. And I will try to share my screen here and see if that works. Okay, good. So I have an app here on my phone which is like a stopwatch, so hopefully it'll keep me on time. The intent is to stay within the 15 minutes on the presentation and keep the floor open for questions. You might have seen me glancing off to the right. I was just looking to see if I recognized any names of attendees, and I did, so that was fun. Okay, so I will proceed here. Okay. So this was just a little bit of background information about where I come from, what I do as a job, and since Mike has already done some of that, I won't spend too much time on that. The other thing that I wanted to make note is that this is always the sort of work I'm reporting on, and is always a result of a collaborative effort. And so you can see some of the people who've collaborated recently on the sorts of things I'm going to talk about today, and they're a fantastic group of graduate students. I work with industry partners quite a bit too, as most of us do at Waterloo, and I'm really happy and proud to have been able to work over the last 10 years or so with the companies on the list here. And then in the previous 25 years, I worked with other companies, but that's less interesting. We also have some great government partners, especially in Canada, to help us leverage industry support for research and development. So I'd like to acknowledge them as well. And then finally, I work with a lot of colleagues at the university in Canada and internationally. So I typically end up working in collaboration. So I thought I'd give a tiny bit of background on, because one of the themes of this presentation is taking a construction technology from research to practice or commercialization. And over the last 30 to 35 years, I just, off the top of my head, last night thought of about half a dozen different areas that I've contributed to in the pioneering phase that have ended up being commercialized and used in practice. Some of those were just multi-skilling utilization and training systems, worked with the Construction Industry Institute down in the States. Site activity analysis, a lot of you know about that for working out direct work rates, wrench time, how you apply that on a site. And we did a lot of that, and that's used in practice by consultants in large companies like Bechtel and Fluor. Critical lift planning, automated materials tracking. We pioneered some of the original technologies and algorithms over 15 years ago. Those are commercial companies that offer that service now. Automated earth moving, 3D scan to BIM, modularization, decision support, all things that I've worked on over the years and have become commercialized or are in practice now. And I, on the other hand, never directly tried to commercialize anything myself. So today, a little bit of more of a story of something I've been more directly involved in. So the last item on the thing there was modularization, and it's something I've worked from a management end on over the last 30 years, but also a little bit more on the engineering and in terms of fabrication and dimensional quality control. In the past, I worked mostly on the types of industrial skids and large modules that you see in the top left and the bottom right, and more recently on the sorts of building type modules that you see in the bottom left and the top right, exterior panels and so on. And this is a project with Edge Architects and Zed Modular and a student of mine who's actually graduated now, Chris Rausch, a specific kind of technology. And one of the things that we were looking at on this project and related ones was how we could produce modules that were dimensionally uh, very tightly made, very precision fabricated, so that we had a product that was actually a higher quality product than something we might stick build. And just wanted to show where this went. It went behind a house in Kitchener. It was got a prismatic boom crane there lifting one of the units in. And Chris has shared a very nice video with me. I won't show the whole thing of what it looked like, the architect's rendering, and that's pretty nice view and a beautiful finish quality on the inside as well. So I'm just gonna leap through this. So one of some of the big issues around modularization over the years and prefabrication and why they weren't adopted as much as they might have been, but are now being adopted very rapidly, is that there were tolerance considerations. Things tended to often not fit, and that created events or incidents on site. And it created structural, aesthetic, functionality, and constructability risks and serious rework events. So this is something that we can use laser scanning to work on. And uh, you can use it in a very sort of engineering approach, very sort of, there's some sophisticated software tools and that typically go with the hardware that you buy from Faro and other scanners. And you can really get some insight into how you can improve on processes in your fab shop or your modularization yard. And you can also do some pretty cool things like scan a frame and then scan the concrete slabs that you're going to drop into those openings in the frame and decide which ones are going to fit best where ahead of time using some sort of virtual planning and fitting algorithms, which we have done a lot of work on over the years. So that's kind of cool. But moving to what is really the theme of today's chat is sometimes you've improved the processes all you can. You've applied lean, you've done other stuff. And you could bring in a high dollar metrology team, engineering team to give you some insights, but you'd really like to come up with a simpler solution. And, we still have this problem in the prefabrication sector that we ship stuff and it doesn't fit, and it costs tens of billions of dollars a year around the world. And we think it doesn't fit and that these processes aren't working perfectly because you've either got the manual measurement tools for these complex dimensions that we've always used, the fitters and welders and steel workers. They work most of the time pretty well, but not always, and that's the problem. So our objective in our research program was to make tools that the craft worker could use or the site superintendent could use, somebody right at the work face that was so simple it'd be like an iPhone or an iPad. We wanted to be able to have these tools work remotely, and we wanted them to facilitate better collaboration up and down the supply chain between the stakeholders. So this involved, we've always got a stream of research, but this particular one involved, I would say, three basic steps. So the first step was to find some cool algorithms. And so we have looked into things like fully convolutional neural networks on point clouds and principal component analysis, iterative closest point, all these fancy algorithms, but they allow you to do things like scan a scene and pull out a particular object and the points associated with that object, and then do stuff with that point cloud. But then the second step was, so that's all fancy. We can do cool stuff in the lab and demonstrate all that sophistication, but we really wanted something simple that you could use on something like an iPad. And we wanted it to just help sometimes with simple things like two-sided isometrics, visualizing an isometric, being able to zoom in, get information, cut sheets, and then visualize what it was you were trying to build as well. So that was the second step. And then the third step was you got to validate all that. So in this particular case, we did about 60 experiments with those pieces of rubber or PVC tubing you see below you and quick connect. And we used the little iPad with the little scanner on it that you see, 3D scanner. And we used the app that we developed, and we just tested with real fitters and real welders. Could you put this fancy spool together quicker if you had this sort of an app? And could you do it more correctly, more often, with less interim kind of rework? So the idea was you'd take a point cloud of the thing that you were designing, which came from your 3D design, and that would be the thing on your left. And then you'd take a point cloud of your scan, which you got from your iPad, and you'd have some tools that would very quickly pull out the information you need and allow you to overlay those things and show with some kind of heat map or graphics whether what you'd built was the same as what you'd designed or not. And so in the previous slide, it was not. In this slide, we're showing that it did. So, okay, roughly on schedule. So that was pretty promising. And we thought, okay, what's the next step? We went to our university development office, a place called Waterloo, and they gave us some advice. And we met with some people we knew in industry, and we formed a startup. And we got an opportunity to go to Velocity, which was a startup incubator at the University of Waterloo. And the team you see below was formed, and it had a couple industry partners as well in the early stages. So what did that team come up with? It came up with not an app, but it came up with a web-based software as a service solution with a number of products. And I'm just going to try to show how it works. So the company is called Glove Systems. And now we fast forwarded, obviously we don't work this fast in real life. Looks like a 1920s movie. But you've got to get the things that you want to scan in the fab shop or the site. You scan them, you get the design information together. So you scan these things from the different angles. You build up some point cloud 3D information of what you've built there. Your software puts all that together. You don't have to worry about that. And then what you do is you superimpose the design and what you've built. So we represent them both with point clouds, and the superimposition is really easy. So you just have to kind of click on a couple places on each one roughly where, and then you get a heat map. And the heat map is basically a way of showing where you're deviating and where you're perfect. And that can be very useful for a lot of things. But you don't want to share just a heat map. You want to share photographs. You want to share reports and stuff like that. And you want to be able to share that on a secure website as well. So, there's a series of related tools that allowed, either from a fabricator or constructor's perspective or an owner's perspective, to share this information securely and view it together collaboratively. So I think this is just showing that you cut and paste a website that's generated. Everybody gets on that website. You can all play with it. Everything's synchronized, and you can visualize before you go to the next step in your supply chain. Okay, so according to my schedule, I'm going to be 1 minute over, but not too bad. I wanted to show you what this all looks like for a more, larger scale module as well. So this is I think a large nuclear plant module. And on the right, you have the 3D scan. On the left, you have the 3D model, uh, both rendered as point clouds. And here you've overlaid them, and you see with the heat map that you got a pipe way out of position. So you share that with somebody in one of your stakeholders in your supply chain. Again, you do that over the internet. It does take a few seconds, but once you've shared it, everybody has their own version that they can manipulate, or you could share your screen and you could, talk about it together. So that's basically how it works. And this is just showing what it looks like when you're sharing it over the internet. Okay, so I just wanted to share this one as well. These are pretty short little video clips. This one is showing what it looks like if you don't have a big module, you just have like a pipe spool or a steel assembly or something. And so you're using this tool both in the fab shop to do the fabrication, to do the checking at various QC points. You could even do it to do the checking of the tack welding or the fit up before you actually do the full welding. And then it can show in this particular case that there was a deviation, and it can show you, I think in the bottom right, the precise number of millimeters of deviation, and then you have to decide whether that's fits the spec or not. And whether it does or doesn't, then you have a different path in your workflow. One would be that you might share some images of the work and your measurements. You might share some reports, some welding records and things like that, and inspection records. And you'd kind of want that to go like a little digital passport along with this thing that you'd fabricated and be able to be shared up and down the supply chain. So I'm going to move on. So this is the last thing that you could do with that sort of set of tools. And it's just showing kind of a future app. This is the idea of being able to visualize how things are going to fit before you put them together, where you've got something you fabricated or designed, like that magnetic or rod array on the left, and you've got the thing that you fabricated that you're going to put it into, and you want to know if you do bolt it flush on the flanges there, whether it's going to fit right. And so here we're using a HoloLens, and we're using some of the tools that came with that Glove Systems service to be able to do that. And what you see there are also those red targets also allow you to do a lot of this stuff even if you don't have a 3D model. Okay. So I'm at the end. I'm 1 minute over already, but I'll just spend the last few seconds on this slide. So the journey that we went through from early research, say 10 years ago, to a commercial product with early adopters is that my original vision was we were going to use this on the shop floor, on the site. Craft workers were going to use it, and they're going to use it to avoid undocumented rework and just make sure we did everything right the first time, and that was going to improve productivity. And as we got further into our understanding of all this stuff, we realized that this was also pretty valuable if you could share it over the internet, as over the cloud as software as a service. It could be useful for supply chain management, supply chain visibility. We also understood that early adopters really saw it more as a risk reducer, so that you're not shipping stuff to the site and having it shipped back. You're not having arguments and claims. You're basically knowing for sure that what you shipped actually fits all the specs. And in a sense, that took us to the next evolution of understanding what we had, which was a trust building tool. That if you have remote fabrication sites and you have a supply chain that's broadly distributed, how can you build up trust that what's being done is being done right, and what you're getting was done right. And then it turned out that the pandemic was both a curse and a blessing in disguise, that everything here can be done remotely. and it just turns out it works great remotely. So that's it. That was the, darn it, I was 2 minutes over, but that does leave time for questions.
So we'll now begin the Q&A session. Just a reminder that if you have a question for Dr. Haas, please use the Q&A box at the bottom of the Zoom window. I'll try to get through as many of your questions as possible in the time remaining. So you touched on a bunch of sort of a fairly large number of possible impacts that are associated with leveraging digitization in prefab and modularization, and some of the mixed reality stuff as well.
Mm-hmm.
To you, which one, and this may be unfair, is sort of the most exciting of the potential impacts that that this tool set enables?
Oh, that's a really good question. I'm just gonna, I prematurely stopped sharing the screen, but I think just showing this last bullet list would help. The most exciting thing, I think, weirdly enough, risk reduction. And what I mean by that is if you are applying these sorts of approaches, you're going to do things right the first time. You're not going to have the events where things don't fit, and you're actually even going to avoid disputes around whether what you did or what you received was correct. So I think in the end, that's gonna result in schedule and cost savings. Um, in the long run, it'll also improve productivity. But the most exciting thing, I think, is risk reduction. And kind of, but there's a lot of digitalization technologies that we're discovering are enabling remote work and remote management. So that I have no idea what the big impact of that, or what's going to be the impact of that over time.
And so when you think about the business
Yeah.
that can best sort of leverage this kind of digitization techniques, are there some characteristics that they have in common to you, or is it all are sort of equally capable of exploiting?
Uh, so yeah, there's things we're discovering. It's going to be easiest to exploit this kind of technology if you're using your 3D designs in your management and fabrication processes. Uh, and it turns out more and more we're doing that. So 5 years ago, you might not have ever seen a BIM. Now you're using a BIM for almost every project. Uh, to what level of development are you using the BIM, and through what phases of the project are you using the BIM? BIM is a building information model, a fancy term for a 3D model with all sorts of other information in it, like schedule and resource loading and so on. But it turns out that so it works great for specialty fabrication shops, for say offshore projects, like complex industrial fabrication. Going to be less of an issue around conventional stick build construction, probably less applicable there. Can be applied even when you don't have a model, mostly for just imagine that somebody's got something that you plan to reuse or you might buy, and you'd really like to know if you can use it on your site or in your building. Wouldn't it be great if you could scan it, and they could ship you that, or just send you that scan over the internet, and you could do all the measurements you want, and you could import that scan into your design and see if it was going to fit before you decided to buy it and they shipped it. So it could be used for things like furniture sales and reuse of building subsystems. So it has an incredible potential, I think.
Which sort of bridges into what one of the questions from our audience, which is about industries or vertical markets outside of automotive, but that has been particularly proactive in adopting digitization technologies you're describing for their product and project development and delivery.
Okay. So sorry. So you're asking, I would say that construction lagged, and even I would say many aspects of specialty fabrication lagged. Mostly because it's really hard to implement the sorts of efficiencies you saw in manufacturing when you're doing small batches or one-off fabrication or unique projects. But in the last 5 years, we've hit a tipping point where modularization and prefabrication has gone from maybe 1 or 2% of the market to 5 or 6, and it's going to double again in the next 5 years. And it just appears that this construction and fabrication uh, and small batch manufacturing are going to have a bit of a revolution, and this is going to be part of it. So it's a short answer, or maybe not as the best answer, but that was my best estimate. Yeah.
And so somebody actually, there we have a question specifically about
Hmm.
the product itself that you guys are working on, I guess, glove systems. So what kind of support is offered with this tool, and what other devices do you need? I guess sort of what's the starting point and support for getting going?
Yeah, it's a very good question. So the support, you can have somebody come out and train you, and it's pretty quick to get trained up on this, because the whole point is that it was meant to avoid bringing in a crew that required you to do a bunch of fancy scanning and then you send it to an engineering shop and it takes them a day or two to analyze it, and then you get some complicated reports you try to understand. So the idea here is that, if you can't learn it in a couple hours, it's not may not be as useful, right? So yeah, somebody comes and they help you train up. It does really help if you have a scanner, and scanners can cost anywhere from $30,000 to $150,000. So that is definitely something that you pretty much need. You don't have to buy a scanner; you can rent a scanner, and the company can deliver a scanner along with the software. So so
Well,
so that's another option.
that's great, and that pretty much brings us to time. So first of all,
Yeah,
I'd like to thank Carl for his presentation. I know I found it extremely interesting, and I'm sure others did too. I'd also like to thank Mary, Kenny, Nicole, and the rest of the team at the CCA who have been so instrumental in pulling the session and the series together. Without them, this really would not have been possible. I'd also like to thank all of you for coming out today. We know your time is scarce and precious, and really appreciate you fitting this into your busy schedule. On that note, we are really focused on ensuring these sessions are as valuable for you as possible. To that end, we've got an evaluation form that we'd really appreciate it to fill out. It should take a minute or so. It should open in your browser if you haven't already closed the Zoom tab. In addition, I've pasted a link to it in the chat window and really would appreciate your honest feedback. It's critical to us continuously improving this.
me too.
Anyway,
I
yeah,
would like honest feedback, please. Yeah.
and so greatly appreciated. And you have the coordinates for Dr. Haas. You put them up earlier, or if you missed them, feel free to reach out to us. We can put you directly in touch. Thanks again for your time, and hope everyone has a wonderful rest of the week.
Thanks, everybody. Yeah. Okay. Bye bye.